My name is Christopher Aboyle, MSc Cybersecurity, MSc Information System Security Options, CISA, CSS, CISSP, CISM, CISM, and CH. We're going to be talking about OSI model overview. And we're talking about computer security from our previous video. We talked about networking, and we said without networking, there wouldn't be anything like cybersecurity. It is only systems that are on the network that can be attacked, that can witness cyber threats. So absolute security on computer system is non-connectivity to the internet. So here we're going to be talking about the OSI model. Remember, we said the model for communication in a network system. Computer network is about OSL model, where we talk about modular compartments of communication in the network. So here, OSL model, which you already know as open system interconnection, is a conceptual framework that is used to understand communication in networking. It's also used for standardization in communication as a networking. All right. The OSI model has 7 distinct layers, and each of them is responsible for specific tasks in data transmission between devices. So, like I said, the physical layer, which is the layer 1, from the diagram here, we talk about the physical layer, starting from this layer 1. This is how the OSI model is, starting from the bottom, layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, to application layer we're talking about. Is the interface layer. You see the arrow where you have transmission, data being transmitted down. Is when you're talking about transmission, you receive from the interface, it's packaged, then you manage the sections, the data for source and destination, the network layer, the data link. Now it comes to the physical layer. Then here, when you receive data, it comes from down to up. So the arrows are there. Then you talk about physical link or medium. Here, having said that, you see that the system, the OSI model, has 7 compartments. It's modular, and each of them responsible for specific tasks in data transmission. So the layer 1 is the one we're talking about now. The layer 1 is responsible for physical connection between devices and the transmission of raw bit streams over a medium. Now, we talk about the devices. Let's define the hardware specifications here. Now, if you look at the diagram, you can see cables. So the function is for connectivity in terms of cables, in terms of connectors, in terms of voltages. It also manages the bits transmissions and the modulation of the transmission. It also handles the signal encoding and the signal synchronization. So the devices that are responsible here that can be connected on this level are the network cables, the switches, the hubs, and even the repeater. The repeater, you know, the repeater is used for extending networks. So example of this is what we call Ethernet cables for transmitting data. You know, Ethernet cables in computer, we have zeros and ones. So what are being transmitted over the internet cables are zeros and ones. So remember, the devices are switches, cables, hubs, repeaters, and so on and so forth at that level. So we have layer 2. On the layer 2, the layer 2 is to ensure reliable node-to-node communication. And it also handles data framing. It helps to detect errors. Talking about layer 2 now, which is the data link. And also, when there are errors, it helps also to correct it. Okay, so the main function of this layer is to provide frames and addressing. Talking about MAC addressing for systems, for the destinations. It also helps to detect and to correct errors that occur at the physical layer, which is the layer 1. Then also manages flow. It controls the flow and access to the transmission medium. The flowing and the access to transmission medium is being managed at this level. Then there are sub-layers within this layer 2. We call it logic link control, LLC, for flow control and error correction, or error checking rather. Then you now have the MAC address, the MAC for access control to physical media, talking about media access control. Okay, then at what level do we have this data link implemented? We have the devices like switches, we have the devices like bridges. So these are the devices. For example, we have Ethernet switches, forwarding frames between devices at this level. They are forwarding frames between what? The devices. So that is what layer 2 does. Then let's look at layer 3. Layer 3, the purpose of layer 3 is to handle data routing. It handles data routing, handles also data addressing and package forwarding between networks. The major function is to provide logic addressing, that is the IP address, to determine the best path for data using routing protocol. Yeah, it manages packets, fragmentation, excuse me, and reassembly. Fragmentation, dividing data, okay, dividing packages properly, and also reassembling the incoming packets. Also, the layer 3, at the layer 3 level, we talk about routers, and layer 3 switches. There are layer 3 switches and routers are the devices at this level. Then the switches, in the protocols for these switches are, the protocols at this level are IP. Then in IP, we have IP4, we have IP6. Then we also have ICMP. We have ARP, that's app. So examples of this are a router that is directing what? Traffic between home and office network. A router that is directing office between a point of presence A to point of presence B. So that's what happened at this layer 3. Then layer 4 is to ensure reliable data transmission between devices. It also includes error detection and recovery. Error detection and recovery. It recovers from the error, from the problem. Then the major function of this level 4 has to do with segmentation and reassembling of data. Segmentation. You segment the data that is going to be transported, received and transported. Then also the function is to cause flow control using techniques like sliding windows. Then talk about error recovery and acknowledgement of successful transmission. It is at this level that there is a report of successful transmission of data. The protocols that are involved are what we call that TCP. And for connectivity, using TCP, you have what we call handshaking, sync. You know what that means? That is in networking. So handshaking, there must be a handshake, and the data from TCP is always what? Reliable. Unlike the second one, which we're going to mention, are the UDP. And UDP stands for User Datagram Protocol. User Datagram Protocol is faster and it is connectionless, but less reliable. Unlike TCP. TCP is reliable. TCP is connection oriented. That means for communication to happen, they must both ends must be in connection. Send a signal and acknowledgement and a signal back. So it's a three-way handshake. Then for the UDP, which is the user datagram protocol, is faster because it doesn't have to sustain any connection. It drops the data, and whether it is successful or not, it doesn't care. It's less what? Reliable. Now, example of TCP is ensuring complete data delivery for email what? Communication. Remember, if you send an email to a client or someone, and if the email is delivered successfully, you will have a successful report. If it's not delivered successfully, it will tell you, it will bring back reports to you. So that is what the TCP does. Let's look at the section layer. The session purpose of the session layer is to manage and control sessions between communicating devices. So the function is to establish, to maintain, and to terminate sessions. Remember when you go for transaction, I said so. Immediately you open a website, a session is open, and it will maintain it. By opening a website, you are establishing a section. Then once that is happened, then the next thing is to continue to maintain that section until you close the website. Then the session is closed. Now, also, the function is to synchronize dialogue and data exchange between what? Applications. That's what layer 5 does. And the protocols here are the NetBIOS and the PPTP. Example of this is keeping a user session open while browsing Presentation layer, which is layer 6, handles ensures that data is presented in a usable format for application and provide data encryption and compression. The functions basically are data translation, e.g., converting EBCDIC to ASCII, or data compression to reduce size, and data encryption for secure transmission. The format could be in JPEG, MPEG, SSL, or TLS. An example of SSL encryption is a secured web page that has HTTPS. The layer 7, which is the application layer. This layer is the closest to the user, providing services and interfaces for communication between applications. Now, the function here is for file transfer, for email services, and remote access. It functions as application-specific operation, like web browsing, like email. Also handles protocol interactions directly that is visible to the user, talking about the interface. Example of this, or the protocol they use is HTTP, FTP, SMTP, DNS, and so on. Example is a user accessing a website via a browser. Use a browser to access a website using HTTP. And the browser is the application, and that is the layer you are using. And the protocol is what? The HTTP. So, in summary, the OSL model is modular, and it is used to identify network issues. I mean, the OSL model is used to compartmentalize, or is used to modularize the communication systems. And this helps to identify network issues at specific layers. So because it's module by module, at any point in time where there is a failure, it is easy to identify, and it helps for modular troubleshooting. So you know where the issue lies, because from one module to another, there's a report of success or failure. Then you talk about standardization. This enables interoperability between devices from different vendors or manufacturers. How about efficiency? It optimizes communication protocols and enhances security. At this modular compartments, you can be talking about individual or specific security for them. I want to thank you for your attention. I'd like us to discuss any questions on the comment session. Thank you for your time.